Good day, everyone. We are the Group 4, and today we will discuss Lesson 4 Properties of Molecules Based on its Polarity. By the way, I'm Eliza May Gumayagay, leader of Group 4. After going through the discussion, we are expected to first describe the types of intermolecular forces present in substances, and second, identify the types of intermolecular forces present between and among substances. We will now discuss the topic. For the first part, may I call on John Riven Revoso?
For the first part, polarity, solubility, and miscibility. One of the practical application of polarity of molecules in a real-life scenario is manifested on the solubility and miscibility of a substance to form a solution. So, what is solubility, you ask? Solubility is defined as the ability of a solid substance to be dissolved in a given amount of solvent. When a solute and solvent are mixed, they form what is called a solution. A solution is only formed when the solute can be dissolved in the solvent. Solubility, a more general term than miscibility, refers to the ability of a substance, specifically the solute, to be dissolved in the solvent. Examples are sugar and water. Sugar is a example of solute and water is an example of solvent. When mixed together, they'll form a solution because the solute or the sugar will be dissolved in the solvent or water. Now, let me call Shinper Gonzalez to discuss the miscibility.
Thank you. So, immiscibility is the ability of the two liquids to combine or mix in all proportions without separation of two phases miscible liquid. For example, water and ethanol are miscible because they mix in all proportions. And miscibility most often refers to liquids but can also apply to gas and solid phases. That's all. For the next part, let me call on Isaac Fundal. Thank you.
The next part is general rule to remember about the solubility and miscibility of molecular compounds can be summarized in a phrase, like dissolves like or like mixes with like. This means that polar substances will only be dissolved or mixed with polar substances while nonpolar substances will be soluble or miscible with another nonpolar substance. Because if you mix nonpolar and polar, they won't be mixed up because they're not in the same league. Like for example, the oil and water, they won't mix because oil is non-polar and water is polar. Okay? For the next part, I would like to call Miss Engay.
Thank you, Mr. Fundal. So, ngayon, i-discuss ko naman sa inyo kung ano nga ba ang INFA. Intermolecular forces of attraction are forces of attraction between unlike charges, partially positive and negative dipoles that occur between two molecules. However, the forces of attraction which hold an individual molecule together, example, covalent bond, are known as intermolecular attraction. A covalent bond in chemistry is the interatomic linkage that results from the sharing of an electron pair between two atoms. The binding arises from the electrostatic attraction of their nuclei for the same electron. Nevertheless, infra differs from bond in that they are not as strong and occur between two adjacent or neighboring molecules and not within the molecule itself. They do from just like bond due to the attraction of opposite charges. May I call on Miss Joya Amare to continue the discussion.
Thank you, Ms. Engay. Now, before we proceed to bond strength and physical properties of covalent compounds, I will discuss to you the types of IMFA. First is the London dispersion forces. They are temporary or weak dipole interactions. It happens between two nonpolar molecules. Second is the dipole-dipole interactions, permanent or strong dipole interactions. It happens between two polar molecules. The third one is the hydrogen bonds. Very strong and very specific dipoles. It is a special type of dipole-dipole interaction. And lastly is the ion dipole. A lone dipole may also interact with a single ion to form this. So this may not be a true IMFA, but we will still call them IMFA. So now let's proceed to the bond strength and physical properties of covalent compounds. Nano. There are several types of IMFA, and below they are arranged from strongest to weakest. Ion dipole, H bonding, dipole-dipole, dipole-induced dipole, and London forces of attractions. So it is arranged from strongest to weakest, meaning that the ion dipole is the strongest and the London forces of attraction is the weakest. It will be further discussed to our next topic. So number 2 is the strength of IMFA greatly affects the physical properties of substances such as boiling point, melting point, vapor pressure, surface tension, and etc. To further discuss this topic, may I call on Miss Kylindi.
Thank you, Ms. Ilaga. From the previous discussion, we learned that there are several types of IMFA and their relative strength as compared to other types. Strong intermolecular forces tend to yield solids and liquid, while weak intermolecular forces favor the formation of gases. Physical properties of substances. A. Boiling point, temperature at which the vapor pressure and atmospheric pressure of a liquid substance n equal. B. Melting point, temperature at which solids become liquid at this point, and then the solid and liquid phases exist in equilibrium. C. Surface tension, energy needed to increase the surface area by the unit amount. D. Viscosity, the resistance of the liquid to flow. E. Vapor pressure, pressure exerted by the substance in its gaseous state. F. Volatility, measures the rate at which a substance vaporize, change from liquid to gas. In the simplest sense, in boiling point, melting point, viscosity and surface tension increase as the strength of molecular forces increases. On the other hand, of vapor pressure and volatility decrease with the increasing strength of IMFA. London dispersion forces increase as the molecular mass of substance increases. That's all for our discussion on Lesson 4, Polarity of Molecules and its Property. Before we finally end this topic, we'll have to wrap up first that will be led by Reza Eunice Dolores.
Thank you. Wrap up. Solubility, the ability of a solid substance to be dissolved in a given amount of solvent. Miscibility, the ability of the two liquids to combine or mix in all proportions, creating a homogeneous mixture. General rule to remember about solubility and miscibility of, of molecular compounds, like dissolves like or like mixes with like. Intermolecular forces of attraction are forces of attraction between unlike charges, partially positive and negative dipoles, that occur when two molecules, boiling point, melting point, viscosity, and, and surface tension increase as the strength of intermolecular forces increases. Vapor pressure and volubility decrease when increasing strength of IMFA. London dispersion forces increases as the molecular mass of a substance increases. And here the reference that we use. Here are the group members who participated and contributed to the group. Male: Rundal Isaac, Graboso John Raben, Gonzales Sheen Pricks. Female: Dolores Reyes Ines, D. Skylin, Engay Crisel Camille, Gumayagay Eliza May, Ilaga Joya Amare. That's all for our discussion. Thank you.